Hi, welcome back in this video series where I will be deploying containers in Elastic Container Service and we'll be putting them behind the application load balancer. Previously, we built a simple application using Fast API, and so in this video I'm going to show how to create a Dockerfile to build a Docker image. But before we do that, I realized that the logic we use to grab the IP address, the public IP address, is not quite right, because we are trying to get the public IP address using this command, call IP info.input/output/IP. It gives public IP address, but our container could be running in different networks. It could be an isolated network from the host. In that case, it may not have access to the host network, and it will not be able to grab this public IP address. So I realized, instead of grabbing public IP address, I think we need to grab the private IP address. Okay, so okay, let's go ahead and change that logic. So how I'm gonna do that? Okay, let's say I want to get the IP address, the IP address of my computer. So how I get my IP address of my computer? The way I do is like this: IP address and show. So it gives this output. But what I need is here. This is my IP address. So in the future, I will be deploying my containers in a VPC with CIDR 0.0.0.0/16. So that's the VPC CIDR I'm planning to, and the subnet size will be with 24 subnet bit. So 10.0.1, that's the network bit, and 0/20. So that will be my subnet size, subnet CIDR. So what I can do here is I can run this command in my future machine and match for /24. So that will give me any line that contains /24. I'm pretty sure that there will be only one line that contains /24, but all I need is only this part of this line. So I'm going to grab that part using awk command, my favorite command, awk tool, awk awk, and I will be, since by default awk use space as a delimiter, so I don't need to tell how to split the field. It's by default it's the space. Now I need to get the field number 2. This is field 1, this is field number 2. So to grab the field number 2, we need to say print $2, and we get the IP address. So I'm going to update this this Linux command in my application code. Okay, so let's open that main.py. That's the application file, and we need to update here. So this time, instead of writing the command here like this, I want to use a variable. That makes life a lot easier. So I will say command command, and so create a new variable called command and put that command here. I hope this works. And okay, now let me run this application. So first of all, let's activate the virtual environment. Source bin activate. The virtual environment is activate, that we can see from that sign. Now we can run this app using a ubicon. So ubicon, and we need to point to the module. The main is the module, and colon the name of the app, and we need to say host. We want to make it we want this application to be accessible from the network. That in that case we need to say 0.0.0.0.0, and if I don't mention the port by default, and this application is listening on port 8000, but I would like to be explicit, so I will give a port argument 8000. So when I run this, yes, it's running now. And what happens now when I use this host equal to 0.0.0.0 in this network? So in my network, if I try to access the IP address of my laptop, I will be able to access this application. Okay, so let's go ahead and try to access this app. I can say HTTP. It's already there, just hit enter. So we have server IP address. Oh, nice, but I did not like this bit, so let me remove that. I will just cancel this one, and I can go to the main.py and update few things here. If I say standard output and strip, this will fix it. So let me run this again, and let me refresh this one. Now it's much cleaner. So this will give us the private IP address. Okay, now I'm very happy with this simple application, which doesn't do much, but it will be sufficient for our demonstration. Now what I would like to do is just cancel that out and build a Docker file, write a Docker file, and using that Docker file we will build a Docker image. Okay, so let's do that. Nano Dockerfile, and we need to say pull the first we need Python to run this application, so we need to run Python, right? And we can use Python as a base image. So pull the Python is the base image. So we can say from, and I'm going to use Python, and let me see which Python version I was using. That's simple, just type Python -- version. So mine is Python 3.10.12. So I will use Python 3.10 and a slim I can use a slim tag so that I can get the small size Python. So when it comes to container, we want to create edge slim edge possible containers, right? So let's do that. From Python colon, after colon we give it a tag. We are giving 3.10 10 hyphen we're using slim1. That's the Python image. After this, we can set the working directory inside the container. So container, we need to mention where are we going to put all the codes. So we need to define that now. That makes our life a lot easier. So set the working directory inside the container. So the command for that is work dir, and let's say, so when during image building process, slash app directory will be created. Okay, so now we just created that working directory. Now we need our source code, right? Our main.py. So we need to copy that from our local machine to this directory. So copy the source code to the container. What we can do is copy dot for current local directory to, that's the current directory in the container, which is working directory we just set here, slash app. Now we need some dependencies to run this application, just like we install UVCon, and we need to have those dependencies. So let's try the command install the required dependencies. Let me save this, and if I list here, I have created requirement.txt file. So I will show you again how I did that. Let me remove this. So all you have to do is pip freeze, because that gives the list of all the dependencies that we are using, and we can redirect the output to requirements.txt file. Now let me edit this requirements.txt file. So it lists all the dependencies, but we don't need to put it everything here. We just can leave it as it is, or just put the main dependencies, for example fast API and UVCon, because pip will automatically figure out the dependencies and it will install. So I will go ahead and delete this, we don't need the sub dependencies. So I will delete this, keep fast API, and yeah, keep these two dependencies, save it and get out. Now open the Dockerfile again. We need to install the dependencies from that txt file, the requirements.txt file. So we can do that easily. Just we need to run, before we use pip to install, it's good practice to upgrade the pip. So I will do that. Pip install pip dash upgrade pip, and after this command is run and successful, we can run pip install -r. But I would like to use one more argument here, which is -r dash no cache and requirements.txt. So what is this? No cache means every time we install using pip, we want to have a fresh installation. We don't want to use the packages in a cache. That's how we get the latest upgrade. So this ensures we have latest upgrade. And now, since our application is already by default listens on port 8000, so in a container we need to expose the port 8000 so that port will be available for the host or in the network. So expose the port 8000. Finally, we need to write a command that when this container actually starts, it will run this program. Right now, everything we mentioned so far, this will be created during the build process, image build process. But when the image is run, it needs to execute this ubicon, right? You need to start ubicon. That's why we need to tell here explicitly when the container starts what to do. If we don't tell anything, the container will die. So to keep it running, we need to run something, and that will keep container running. Run the app with ubicon. So we can say here entry point, that's the command, and we can give the command here with inside this square bracket. The first command is ubicon, because ubicon will be available in the path, so we can say ubicon comma. Second is the name of the application. So what we can do here is in our Dockerfile, so we can either use environment variable to say this is the main module. For example, we could say env, and we can say module name equal to main. That's also possible to do. Then we need to say, if we go with that, we need to say $module name. Or if you don't want to use this environment variable, then simply we mention the name of the module, which is, we know the name of the module is main colon, and the name of the app is app. And we want this to be available on the network or on the internet, so simply 0.0.0.0, and the port will be 8000. Okay, so let me cat this Dockerfile. So we have used Python 3.10/slim as a base Python image. So everything will be built upon this Python, which is the main dependency for our app. And we are creating /app directory inside the container. And we are copying everything from the current directory, this dot means current directory, to the current directory of the app, container, which is /app. And we are running upgrade for the pip and installing dependency using the requirements, the text file. And we are exposing our container on a port 8000, so it will be available on a port 8000, And finally we have our entry point here, which tells container to run when it starts. Okay, with this information now we should be able to build build the image of our app. So before I go ahead and build, there are some images that I already have created. I'm going to delete them first, and I will show you how to delete the images. So Docker images. So we see there are a lot of images here, and I have created this, and I'm going to delete them. So it's very easy to delete. So for image in app version 1, app version 2, app version 2, version 3, app version 5. Okay, this will let me write straight, simply docker rmi, and here just need to provide this image id and hit enter. That's been deleted. And grab another image id, provide this, hit enter, provide another image id, yep, and another image id. Okay, let me check now. Docker image ls. So still we have one image that we want to keep it clean so that we can see what's happening. Docker rmi and this one. Okay, so I will be keeping these two images that I need so for my future demo. Okay, now we're good. So now let's go ahead and build an image. But one thing I almost forget to tell: to build an image, we don't need few things here. We are copying everything from current directory to the container. We don't want to copy this one and this one as well as Dockerfile. So what you need to do is we need to create a Docker ignore file, and we can mention this folder and file name in that Docker ignore file. Let me do that. So actually I believe I have already done it. It's called .docker. Okay, let's do that. Echo Dockerfile to .docker docker ignore. So we don't need to copy docker ignore. We don't need to copy this as well. We don't need to copy readme. We don't need to copy VNB. This is a very important step, because copying all these things which we actually don't need to build an application of image, that will just increase the size of the image. So it's a good practice to create .docker ignore file and put there all files and folders that we don't need to run this app, right? Now let's cat this dot docker ignore. So Dockerfile is there, and this pycast directory, readme, and this. So this will not be copied while building image. That's all good. Okay, clear. Let's go ahead and build the image. Docker build -t. So we provide the tag here. I will call it app colon v1 is a version, and give the current context. Once I hit enter, it will go ahead and build an image. Okay, we have some problem here. What is it? Okay, looks like the line -r, this seems to cause a problem. Let me check if I can pip install okay, go ahead. All I need to do is, I guess, no cast, this -r option should be here. Save it and let me run from here. Okay, so let's check docker image ls. So we have our image here. We just created app, I mean the image of our app. So it has a tag v1, and we can also explore other options. For example, we can docker image inspect and app colon v1, and it will give us a detail about our image. For example, few things that we can know is a repo tags which we provided app v1, and so this one working directory that we provided, and the entry point is here, ubicorn main app host this, and I believe it should also have that exposed, I must have, yes, exposed ports is 8000 TCP. Yes, this is good. So now what you can do is, we can run this app and see how it works, right? If it works in this local environment, then it's ready to be pushed into Elastic Container Registry. So we need to first make sure it runs in this control development environment. So that's what we will do now. So we will run this app here, but I'm going to run this app in a Docker has 3 different types of network. If I remember correctly, the first one is a host network, so which is like attached to the host. If we expose any port, let's say 8000, that will be only available on port 8000 on the host. Second one is the bridge. So in a bridge network, which is isolated from the host, that means we can have many ports, different ports, but all mapping to the single port on the host. And the another one which I don't remember, but I can show you here. If you run docker network ls, yes. So the third one is we have like a bridge and the host, and another one is null. Well, I'm not sure. Okay, I don't want to go into detail about that. So let's run this app in the host network. Okay, docker ps. Right now there are no application, no container running, which we can see. Or docker container ls. This is the command that shows us if there are any container running. It will show us. Right now nothing we see, so no containers are running. Let's run this app. Docker run in the background. I want it to run in the background, so -t. I want to give it a name, so name is app, and the network, I want to place this in the host network. So when you place in the host network, what happens is the port at which the container is listening on, that same port will be mapped on the host. Okay, so we cannot have different ports. Since our container is listening on port 8000, so we will be access our application on port 8000. Network host and the name of the image, which is app:v1. Everything looks good to me. I will run this, and I got this, the number. Let me log it. Docker logs -f, name of the container. Oh, we see that it's working, running on a http:// So let's try to access this port 8000. That's the old one. Let me delete this one and run here. http, yeah, server IP address is interesting. We don't see the server IP address. I thought I fixed that problem, but still we have that problem here. Well, I will look into that by myself, but as of now it will stay like this. Let me check if it is healthy. That's what I'm very interested to see. Health status is okay. That's good. That's all we need. Okay, as of now. So I will, now we have our Docker image ready. So in the next video we will be creating a repository in Elastic Container registry in AWS, and we will be pushing this image into that repository. So I will use AWS command line to do that. See you in the next video. Thank you.